All right, so this is 310, trig equations and inequalities, but we're going to equations today. All right, so let's look at equation 1 and equation 2. So is sine x equals 1/2 the same as arc sine of 1/2 equals x? And so that's kind of what we're going to talk about right now. And so when is sine 1/2? This is sine x equals 1/2 when? When does it happen? At pi over 6. Does it happen anywhere else?
Yes.
Where? At 5 pi over 6, exactly. All right, and so sine x is equal to 1/2 at pi over 6 and at 5 pi over 6. But what if I go around my circle again? Then it'd be like 13 pi over 6. And wouldn't sine of 13 pi over 6 also be 1/2? And so it happens every period of sine. And so that's what that one is. And so let's look at equation 2. Arc sine is bounded by what? By 1 and 4. And so this is between negative pi over 2 and what? Pi over 2. So arc sine of 1/2 is equal to what? Pi over 6. Is there another option on that one? No. And so are these two equations the same? They are not actually, because this one has such a domain restriction on it. All right. And so let's talk about that today. And so when we're finding general equations, all right, I don't need to read all of this, but when we're finding general equations, we have to be worried about the period of the function. So what is the period of sine and cosine? 2 pi. And so when we're dealing with this, we're going to say it's like pi over 6 plus 2 pi k, because the period of sine is what? 2 pi. All right, and so we'd have pi over 6 plus 2 pi k. And then we'd also have 5 pi over 6 plus 2 pi k. The same thing with cosine. And so cosine's period again is what? 2 pi, and that's why we're going to add this 2 pi k to it. However, the period of tangent is what on this one? Pi. And so that's why we're adding the pi k's to it. Just like our vertical asymptotes of tangents happen every what? Where do vertical asymptotes of tangent happen? At pi over 2's. Plus what? Pi k, because they happen all those periods. All right? All right, so we're going to find all the solutions of cosine x equals negative square root 2 over 2. And so when does cosine equal negative square root 2 over 2? 3 pi over 4. Where else? And at 5 pi over 4. Now, does it happen more than that? It does. All right. Now, not on one of my unit circles. However, we always have to be worrisome of the period. So what's my period of cosine? 2 pi. So we're going to add 2 pi k to these. And so I'd have 3 pi over 4 plus 2 pi k and 5 pi over 4 plus 2 pi k. All right, let's keep going. So example 2, we're saying sine x equals negative 1. So let's think about our unit circle again. So when does sine equal negative 1? At 3 pi over 2, exactly. And so now we'd have x is equal to 3 pi over 2. But do I have a restraint on just one unit circle? No. And so what should we add to it? 2 pi k. All right, where k is that integer. So it's that constant that we're adding. All right, so let's do it again. So we're going to find all the solutions of tangent equaling 1 over square root 3. Now, this one was not rationalized, but like, how do we get 1 over square root 3? What is that really going to be? It's like 1/2 over square root 3 over 2, right? And so tangent, how do we think of it again? The y over x. So when is my y 1/2 and my x square root 3 over 2? When's that happening? At pi over 6. Now, does it happen anywhere else?
Yes.
Yeah, where else? It happens at 7 pi over 6, because it'd be a negative negative, wouldn't it? Yeah. And what happens when you have a negative negative? It cancels out and makes it a what? A positive. And so we'd have x is equal to 7 pi over 6 as well. Now we have to be worrisome of our periods. Well, what's the period of tangent, though? Just pi. And so what do we add to these now? Plus pi k. But this one we don't need both. And I want to talk about why we don't need both. So if we look at pi over 6 and we add pi to it, pi is how much around my circle? It's halfway. And so if I go halfway, guess what it goes to? 7 pi over 6, right? And so I don't actually need this one. Because if I add just pi to it, it actually goes on top of the 7 pi over 6. And then it'll go again, and it'll go back to the pi over 6, aka 13 pi over 6. But really, it's just going to keep going in that circle and just going on top of one another. All right? And so we don't actually need the 7 pi over 6 plus pi k. Solve trig equations.
Isolate the trigonometric function on one side of the equation. Find the corresponding angle measures on the unit circle that satisfy the given equation. Consider any domain restrictions in the problem and write the solutions and/or the general solutions.
What we need to do is we need to isolate the trigonometric function to a number. So we need to solve to get my trig function equal to a number. All right, and so let's look at example 4. So I have 6 sine of theta equals 3 square root 2. I don't have a trig function equal to a number yet, so what do I have to do to both sides? Divide by 6, exactly. So we're going to divide by 6. And so now we'd end up with sine theta is equal to 3 square root 2 over 6. Well, what does the 3 over 6 simplify to? 1/2. So that's square root 2 over 2. All right. So the first step was to get the trig function equal to a number. And so very similar to what we've done before. So when does sine equal square root 2 over 2? At pi over 4. When else? And at 3 pi over 4. Exactly. Now, I don't have any constraints on this one. So what's my period of sine? 2 pi. So now I have to add plus 2 pi k's on them. So now I have plus 2 pi k. And so those are my solutions to that equation. All right, cool. Let's look at example 5 now. Ethan, pick a reader.
Probably trace. Let f of x equal 3 plus 2 cosine x and g of x equal 2. In the xy plane, what are the x-coordinates of the points of the intersection of the graph of f and g for 0 is less than or equal to theta greater than 2 pi?
All right, fantastic. All right, and so anyway, so now we have a constraint on this. And so what this means is it's going to be on one of my unit circles, okay? And so what does the x-coordinate for point of intersection mean? What is an intersection? What do we do with that? We set them what? We set them equal. All right, to find out where they intersect is where we need to set them equal, okay? Because that's where they'll be the same. And so now we're going to set 3 plus 2 cosine theta, or cosine x, I'm sorry, is equal to 2. So the first step is to get my trig function equal to a number. So let's do 2 steps. Here we go. What's my first step?
Minus 3.
Subtract 3. So what do we get there? Negative 1. Then what? Divide by 2. So cosine x will equal what? Negative 1 half. All right. And so now I have to think about my unit circle. So when does cosine give me negative 1 half?
11 pi.
At 2 pi over 3. And when else? And at 4 pi over 3. Do we add 2 pi k's to these? We do not, because now I actually have a restriction on one of my unit circles. All right, keep moving. I'm not going to read all of this, but I do want to talk about a couple things. All right, so if we have sine x squared, the x is being squared. It is not the sine being squared. However, if we have sine squared x, that really means the quantity of sine x squared. Okay, I'll have students mess this up a decent amount, and so we need to understand what that means. And so let's say if I have like cosine cubed x, what that really means is I have cosine of x cubed. Does that make sense? And so it's very different than like cosine x cubed. So this is really like x cubed, and then I have the cosine function that I'm doing on it. All right, and so anyway, so there's just some notation issues that I see commonly. All right, so let's look at example 6 now. Trace, pick a reader.
8.
The function g is given by g of x equals 3 minus 4 sine squared variable x, where the zeros of g on the interval 0 is less than or equal to theta less than 2 pi.
All right, fantastic. What's a 0? What's that another name for? An x what? Intercept. It's an x-intercept. So how do we find an x-intercept? We substitute 0 in for, not x, but the y. If I substitute 0 in for the x, that would solve for my y-intercept. All right? And so now I'm going to just set this equal to 0. So now I have 0 equals 3 minus 4 sine squared x. All right. All right, so on this one, I need to get my trig function equal to a number. So what do I do first? Subtract 3, then what? Divide by negative 4. So now I end up with sine squared x is equal to what? 3/4. I still don't have a trig function equal to a number because my trig function is being squared. So what should I do to it? I should square root it. And so when I square root the sine squared, I just get sine x. That's good. However, when I square root something, what do I actually need out front? A plus or minus. All right. And so when I square root something, I need a plus or minus. And then I have a square root of 3 over the square root of 4. Well, what is the square root of 4? 2. And so then when I square root both sides, I have plus or minus, and then I have square root 3 over square root 4, aka 2. All right. Now, when is sine positive or negative square root 3 over 2? At every pi over 3, exactly. So x equals what? Pi over 3. When else? 2 pi over 3. When else? 4 pi over 3. When else? 5 pi over 3. All right. Now, the 4 pi over 3 and 5 pi over 3 are negatives, but that will give me sine being negative square root 3 over 2. All right. Pretty good there? Cool. All right, let's look at example 7 now. Kyler's going to read for us.
What are all values of theta for 0 is less than or equal to theta is greater than 2 pi, where cosine squared theta equals negative cosine theta.
Cool. Love it. All right. And so I have the interval from 0 to 2 pi, and then I have this one. So the way that we can think about this is like it's x squared is equal to like a negative x. Okay. And so that kind of helps some students sometimes think about it. I need to solve for x basically. All right. But in this case, I need to get cosine equal to a number. But before I even deal with the cosines, I kind of want to work with the x's. So without dividing by x, because that's going to cause bigger issues, how could I get this on the other side? What do? I just add it, right? And so then I get x squared and then plus x is equal to 0, right? And so then how could I start solving for x? What could we factor out on that one? We could factor out another x. So then I'd get x and then times what? X plus 1, right, is equal to 0. And just like we've done since Algebra 1, we use the zero product property. So I set x equal to 0. And I'd set this x plus 1 equal to 0. Okay, remember how to solve that back from Algebra 1 days? All right, so we're going to do the same thing, except now they're going to have cosines and thetas and tangents and sines and all that good stuff. All right, and so let's work with it now. So on this one, I know some of you will want to divide by cosine. However, that will get rid of something, and I want to talk about what that will do in a sec. All right, and so what we're going to do is we're going to add it over, just like what we did on the other ones with our x's. And so now I'd have cosine squared theta is, and then what? Plus cosine theta is equal to 0. And so now what could we do with the cosine? We could factor 1 out. And so now we'd have cosine theta times what? Cosine theta plus 1. is equal to 0. And so now we're going to set both of these products equal to 0, okay? And so now I'd have cosine theta is equal to 0, and I'd have cosine theta plus 1 equal to 0. I will usually kind of work that step a little bit quicker. And so cosine theta is equal to what? -1. All right, normally I will jump from here to there, all right, because I think we can handle that. All right, and so now we have to evaluate. So when does cosine equal 0? At pi over 2. When else? At 3 pi over 2. All right, and so then when does cosine equal -1? At pi. All right. And so those are my answers on that one because I have a restriction from 0 to 2 pi. Now, on a multiple choice question, they will do it in ascending order. And so they'll rearrange it as like pi over 2, pi, and 3 pi over 2 as their answer. All right, even though you're going to solve it that way. All right. Now, the caution I have for you is if you divide by cosine, you're not going to get these two answers. And these are two answers that we want because these are solutions to that equation. All right. So don't try to get rid of things like that. Just move them on one side and work with each other. All right. So let's look at example 8 now. Aiden, pick somebody.
David.
Let f of x equals 2 sine squared x and g of x equal square root 3 sine x. In the xy plane, what are the x coordinates of the point intersection of the graph?
All right.
Of the graph of f and g for 0 is less than or equal to theta, which is less than 2 pi.
All right. Fantastic. So again, I'm looking for an intersection. So what do we do for an intersection? We set them equal. So we're going to set 2 sine squared x and then is equal to this square root 3 sine x. All right. And so what's my first step? Subtract. Okay, we're gonna move this one over. And so now we'd end up with 2 sine squared minus square root 3 sine x is equal to 0. And just like before, what can we do? We can factor out what? A sine x. And so now we'd have sine x times what? 2 sine x and then minus square root 3. All right. And so now I have these two products that I'm going to set equal to 0. So I'm going to set the sine x equal to 0. And I'm going to set sine x equal to what? I think you can do these two steps. You're going to set this equal to 0. So what'd you move around?
Square root 3.
You added square root 3 and then you divided by 2. And so now I have is equal to square root 3 over 2. And so now we can just solve both of them. So when is sine 0? At 0. When else? Pi. Now, do we actually say 2 pi? No. Why not? It's less than 2 pi. All right. And so we have to be aware of that. 2 pi is not included on that one. So it's just 0 and pi. All right. And then this next one, when is sine square root 3 over 2? At pi over 3. When else? And at 2 pi over 3. All right. And again, this is just fine if it's free response. However, if it's multiple choice, they're going to go in order. And so it'd be 0, pi over 3, 2 pi over 3, and at